Hello everybody, we are in week 8 of this particular course, and in this class we shall start discussion on register and shift register, and we shall have a quick recap of what we had in the previous week, and then we shall go into the new topics. So, if you remember, we discussed flip-flops in the previous week. Its various representations in the form of truth table, characteristic equation, excitation table, state transition diagram, and then we understood the issues that could be there with level triggered flip flop, for which edge triggered flip flop is advisable, which ensures only one transition per clock cycle. And we also studied asynchronous preset and clear input, how it performs and how it changes the output or the state without requirement of a clock trigger, and which is useful for initialization and various kind of resetting purposes. And we also looked at analysis of simple sequential logical circuit and synthesis also from the point of viewpoint of conversion of flip flop from one type to another. And mostly we dwelt on flip flop as an individual unit. Okay. So, now we start discussion where we look at flip flops as a group. Okay. So, register is a group of flip flops that can be used to store binary data. Okay. And if we think of, say, a binary number, say 1001, if you want to store, then we need, of course, 4 flip flops. Okay. So, the larger the number, larger the information, then we need as many number of flip flops, and together we are, say, doing some manipulation. So, it will be a register level manipulation that we are doing, okay, where all the flip flops within that particular group are addressed simultaneously, are considered simultaneously. Okay. So, for a 8-bit flip flop, 8-bit register, we will be having 8 flip flops, and the way we have seen them, if we want to write something, that 8-bit number or 8-bit information, okay, and then read from it, then the way we have done it before, we can think of providing a specific inputs, okay, to those flip flops and then reading it from the output. Okay. So, directly loading it from the input side, the way the flip flop truth table tells us, okay, if it is a D flip flop, then 8 such flip flops, so 8 such D inputs will be there, and the reading will be from the 8 Q outputs. Okay. And if you want Q bar, then Q bar also can be made available. So, that is the way of writing and reading. The way we have seen it before is called parallel data input, and reading is parallel data output. So, in short, parallel input, parallel output, or PIPO. Okay. So, this we have already seen, and the data writing is done through clock trigger, of course, synchronous with the clock. So, in one clock cycle, the data is coming to the flip flop outputs, okay, and reading we can do as many times as we want, just by accessing the output values of the these flip flops, these 8 flip flops. Okay. Is it clear? Now, one issue that might come from storing larger number of bits in the form of a group, the number of input output port or pins that will be required. So, if it is a 8-bit flip flop, so you can imagine, so 8 input pins will be required here, okay. Then 8 output pins will be required here, and if you want Q bar, then of course another 8. So, even if we do not consider Q bar, so 8 plus 8 16, then VCC, ground, then clock, then usually there is a asynchronous clear for initialization purpose. So, you can consider, you can think of how many pins will be required, and standard packages we have seen are 14 pin, 16 pin and all. So, this is going beyond that. Okay. And so, for larger number of bits where we want to store and then retrieve, these parallel in parallel output may be an issue. Okay. So, you have to think of alternative, and when you think of those alternatives, one idea that comes is to make it serial in. So, then comes the discussion or the topic of shift register. Okay. But then when you talk about conversion from parallel to serial, time to read or write becomes a issue. Okay. And the other issue that comes into consideration is when you are reading it, you are pushing the data out of this shift register. So, the data may be lost. So, all those things we shall discuss in detail in today's class. Okay. And to get an idea about how to handle binary information which is of consists of larger number of bits. Clear? Okay. So, PIPO we have seen. Now, let us look at three other types. One is serial in, parallel out. Okay. So, what is happening here? So, data is coming to the register serially. Okay. So, one bit at a time. So, to push 8 bit of information, you need 8 clock cycles. Okay. So, in each clock one data will be pushed. So, only one data input is sufficient, serial data input is sufficient instead of those 8 that was required. Okay. And reading is through parallel outputs. Okay. So, then you are saving on the data input side number of pins. Clear? So, as many number of times you want to read, you can read it, no issue. Okay. So, this is one particular type. Okay. The other type that can be there, that data is sent to the register parallelly. See, in one clock cycle all the data is getting loaded, unlike the previous case. Okay. And then the reading part of it, okay, the first data that is in the inmost say flip flop, that is available, and then you need another, so if it is 8 bit, so another 7 cycle to push data out of the flip flop. We shall see actual circuit and other things we shall discuss elaborately later with examples. So, that will be required, and at that time, since the data is being pushed, so these data as such on its own will be lost. So, that becomes a destructive reading. And the third option is the fourth option here, other than PIPO, SIPO and PISO, parallel in, serial out here, serial in, parallel out there, is serial in, serial out. So, that requires the least number of pins. So, data is introduced in the register serially with say 8 clock cycles for 8 bits, and data is read also serially using the clock. So, data will be going out one after another. Okay. So, to prevent this data being lost and all, so you can have a feedback kind of mechanism that we shall see later. Okay. So, we said that we shall look at actual circuit that are used. Okay. So, the first thing that we see is a PIPO, parallel in, parallel out, which we are already familiar with in one single flip flop form, one unit of flip flop that we have seen how it works. So, this is IC 74174. So, this is a 16 pin package, you can see, right, and it has got 1, 2, 3, 4, 5, 6, right, 6 flip flops. So, 6 bit data you can store here, right, and for that there are 6 outputs, okay, and corresponding to that there are 6 inputs. So, whenever clock trigger comes, the clock is common, right, and if you look at this inverter here and inverter here together, then it is a positive edge triggered. So, whenever the clock trigger comes, whatever is the data, 6D here comes to 6Q, okay, directly. Similarly, 5D comes to 5Q, 4D to 4Q and 1D to 1Q. right. And if you are looking for resetting it, clearing it, then you can do all the flip-flops together, right. So, it is a common clear. So, it is 2 bubbles here and then a bubble. So, basically it is active low. Okay. So, if you put a 0, right, irrespective of the other values, you will see that it is it will become reset. Is it okay? Okay. So, the number of pins, as you see, as many number of inputs and as many number of output, and parallelly it is getting loaded in one clock cycle, and you can do as many times of reading as you want without any issue. Okay. Now, there is IC 74175, in which both Q and Q bar outputs are made available. Say in some application you require it. Okay. And it is a same 16 pin package, which is similar to other 14, 16 pin packages that you are normally used. Okay. So, then since both Q and Q bar are there, so you have to sacrifice the number of bits, number of flip-flops that you can put inside the package. Okay. So, it is a quad. So, 4 D flip-flops are there in that particular IC. Okay. So, this is the issue with parallel in, parallel out. Okay. But it is also useful and you can make use of it depending on your requirement. So, next is the other extreme. Let us see, we shall look at SIPO and PISO also in subsequent classes. Okay. So, SISO, this is again another practical circuit which is put into use through IC 7491, okay, that we discuss here. So, in this what you see is it is a 1, 2, 3, 4, 5, 6, 7, 8 bit of information you can store here, 8 bit of information. So, had it been parallel in, parallel out, you can imagine 8 plus 8, 16 and so many other things that we discussed before. Okay. But because it is a serial in, serial out, so a 14 pin package, a standard 14 pin package is sufficient, and in that also you can see there are so many of no connection, it is not required. Okay. NC stands for no connection. Okay. So, you have got a clock input, common clock which is triggering, a QH and QH bar, because there are pins available. So, you take both the Q and Q bar as the serial out, right. And additionally, you have got A and B, where B you can consider as a control input. So, when B is 1, B is high, then whatever is the change in the A, that goes to the flip flop. I mean, the flip flop is loaded accordingly, according to the variation in A. Okay. And if B is 0, then it is all 0 that is coming over there. Is it fine? Right. And you see that there is no asynchronous reset as such, asynchronous clear. So, with B kept at 0, control input, and if you feed the clock, then after 8 clock cycles, all of them will take the value of 0. Is it fine? Understood how this is organized? Now, let us look at how this particular circuit can be used for, I mean, how such SISO thing can be used for writing. Okay. So, here we look at an example where I mean, we can use any type of flip flop depending on our requirement. So, here we are using JK, we shall see example with SR also, D we have just seen. Okay. So, in JK flip flop what we are doing, we are just making sure that whatever is placed at J, K will be just opposite of it. Okay. So, you can see in this timing diagram the serial input that we are having. So, if you have a J here 0, the corresponding K is 1, 0, 0, K is 1. Whenever it has become 1, immediately it has become 0. So, that is ensured. You can put an inverter and all at the between J and K, okay, and feed the data from J. Okay. So, that is the idea. So, that is the way you can do it. It is very simple, right. So, effectively it becomes a D flip flop, right. Okay. Now, whatever is there in the serial data input, in the beginning. So, we consider only the j part of it, k is just a inverted version of j. So, let us consider that there is a 0 present here. Okay. So, with one clock trigger, so this 0 goes to this place, that is flip flop q. So, we are naming it q r s t, right. So, q acquires this value 0. So, that is how the arrow has been shown. Is it fine? And there could be some value present earlier in these flip flops. So, you do not need to bother about that, because we are talking about writing a 4-bit data into this 4-bit shift register through serial input. Okay. This is what we want to consider. Otherwise, it could be 0 or 1 depending on whatever is there. Okay. So, when you complete the writing operation, that data is lost, of course, right. So, so next value that we put is 0 at the input. Okay. Clock trigger comes, what will happen? This 0 will come to q, and this q output is connected to input of r. So, this 0 now comes to 0 that was there over here. In the next time point, it comes over here. Is it okay? Right. The other two we are not bothered. Now, you present 1 at that time. Okay. With next clock trigger, 1 comes here, right, just, and this 0 comes over here and this 0 comes over here. Okay. So, S now has got 0, R has got 0 and Q has got 1, and before the next clock trigger occurs, 0 is presented at the input. What will happen? So, this 0 will come to Q, this 1 will come to R, this 0 is coming to 0 and this 0 is coming to 0. So, 4 clock cycles have elapsed, okay, and now Q, R and S T are having value 0, 1, 0, 0. So, 0, 1, 0, 0, right. So, if you want to store say 0, 0, 1, 0, so you can imagine that first you have to give 0, then instead of 0, 1, 0, 0. So, if it is 0, 1, 0, 0 kind of thing, next you have to give 1, then you have to give 0, then you have to give 0. Okay. So, this is the way you have to plan your entry of serial data input, okay, depending on what you want to store here. Is it clear? Okay. And the example is given through timing diagram, right. So, what is of importance here is the clock edge, right. So, it is a negative edge triggered, that you can see, this is the negative edge, okay, at which it triggers. So, at that time whatever is the value that is present at for j. So, here it is 0. So, q, okay, q r s t initially it is has been considered, it is 0. So, this 0 will be coming here, okay. This is the one that we are talking about. The next value is 0 here before the clock trigger. So, this 0 is coming here and this 0 is coming there. It is through the timing diagram, same thing, okay. Now, before the next clock trigger, you see that it has changed, and when the clock trigger comes, it is 1. Okay. So, this 1 comes here, and this 0 comes here, and this 0 comes here in the next clock time period. So, this is the way the time is changing, right. And after that, before the next clock trigger, 0 is there. Okay. So, this 0 comes here, this is already mentioned. So, this 1 comes here, this 1, okay, this 0 and this 0. So, ultimately 0, 1, 0, 0 at this time point you shall see in this clock cycle, okay, after 1, 2, 3, 4, 4 clock cycle, 4 clock trigger. That is how the writing is done. Is it fine? Okay. So, now we look at reading of it. Okay. So, we considered that initially it has been stored with 1, 0, 1, 0, and this is the serial data out. Okay. So, 1, 0, 1, 0, this is with which the flip flop is occupied with. Okay. And then one clock trigger comes. So, at the input side it could be anything, whatever is there that would be pushed. If it is 0 or 1, it will be pushed. Okay. But we are just doing the reading operation, and as you know that the way, if we just read it this way, something else will come here which is not the actual data. So, that's why it is becomes a destructive reading. Okay. So, in the first clock pulse, this 1 will be coming over here, this Q is the input to this flip flop. Okay. So, now this is a D flip flop based shift register. So, this 1 comes here and this 0 will come over here and this 1 will come over there. Okay. So, in the first, before the application of the clock, as it is, you can read 0, okay, and then after application of 1 clock trigger you can read 1, the information there. Then one more clock cycle, this 1 will come here and this 0 will come here, you can read 0 over here at the serial data out at the output of T, and finally one more clock trigger, you can see 1 over here. Okay. Right. So, this way, in this case, since already one of the output was available, accessible through serial data out. Okay. So, 3 more clock cycle, you have got 0 1 0 1, all the bits read by this. But in this process, now the flip flop except this one, which is having the value of Q, rest of the values are, you can say garbage, or you can say something else, but not the one that you have read. Okay. So, this is, by this you are actually having a destructive reading. Okay. So, that means the data is lost. Okay. And this is shown through the timing diagram. Okay. So, in this case, this 1 0 1 0, you can see this is the way, and if you have if you are inputting 0, then at the input side, then finally the values will become all 0. If this was all 0 being inputted over here, then one more clock cycle, all zeros will be coming. Okay. And the serial data out that you read over here is like this. Is it okay? 1 0 1 0. So, first you will read 0 here, then 1, then 0 and then 1, and if you continue to give 0, so 0 will come here. Now, if you are interested in reading the data multiple times, not that once you read it the data is lost. Okay. So, you may need in an application that you want to read the data multiple times. Okay. It is not that you write once, that usually is the case, write once and read many times. Then you need to see that for parallel in, parallel out, there was no issue, isn't it? So, parallel out you can read it as many times. So, now no data is getting lost unless you are reloading it. Okay. But in serial out, we have seen that while you are reading the data from the output terminal, what is being shifted either 0 or 1 or any other value. So, original data is getting lost. Okay. So, one way to prevent that and affect multiple time reading is to use an external feedback. Okay. So, the one that you see as a connection like this. Okay. So, what happens in this particular case? What you are doing actually is every time you are reading something, okay, except for the first case you are reading it just like that first bit. So, whenever you are reading the next bit, say S, you are writing this bit back over here. So, reading and writing are happening simultaneously, and now you need 4 clock cycles, so that you are back to the data that you are originally started with. Okay. So, if you had originally say 1 0 1 0, okay, you can read the way we have seen in the previous example. So, 0 1 0 1, so because you are starting with 0 only. Okay. So, you can complete the reading what is there in 3 clock cycle, but then you will be having 1 over here. Okay. And you want to get back the number in its original form, then you need 1 more clock cycle. Let us see how it happens. Okay. So, this is the original one 1 0 1 0, with which you start the reading process as well as simultaneous writing through a feedback, and at that time, since this is 0, this 0 is fed back. this 0 is fed back here. Okay. So, with next clock trigger what happens? This 1 comes over here, this 0 comes over here, this 1 comes over here, and you can read this as 1 like the previous case. Okay. But at that time what you see, because of the feedback, this 0, the information that was in T, now is getting written and it comes to Q. Okay. So, information of T 0 as 0 is not lost, it is coming back. Now, you have got 1 0 1 and 0 here. Earlier this was 1 0 1 0, now this is 1 0 1 0 and this. Is it okay? Another clock, okay, and that time this 1 comes over here. Next clock. So, this 0 will be pushed here, okay, this 1 will be pushed here, right, and then this 1 comes to this place at Q, and R gets the 0. Okay. So, right now this is 1 0 of the previous one and this is 1 0 which is written back, and this 0 is coming over here. So, again one more clock cycle, this 1 will be coming and this is this will be in your red color. So, this is 0 coming here and this is 1 and this is 0. Is it okay? And this one is fed back here. So, earlier in the clock cycle this reading was complete, 0 was originally available and 1 0 1 we have read in 3 more clock cycle. Now, because we want to read it as many number of times and you want to store the information in 1 0 1 0 form, okay, one more clock trigger. So, this one comes over here and this one is coming back and 1 0 1 0 you get back. Okay. So, reading and writing is happening simultaneously. So, this is your non-destructive reading in a shift register where SISO option is only available. Okay. Now, if you want that you want to read it this way and also you want to write through external inputs the way you have seen. So, would you like to disconnect or again connect the serial data input, that is possible. Okay. Or you can think of a 2 to 1 multiplexer kind of mechanism by which this input D over here for the first flip flop. Okay. So, D1 okay, is a select input. So, when it is 0, say you are doing the reading. Okay. So, that will be your this T plus when it is 1 you are doing the writing. So, that is the serial input. Okay. So, you just need to have a small circuit, logic circuit over here by which if you put it in this manner, then it will be external writing when S is equal to 1. So, this is serial in and this is external writing, and S is equal to 0 internal writing, which is nothing but non-destructive reading. Is it okay? Have you understood this part? SISO, how it works and how we can make use of it, and PIPO we have already seen before. Okay. So, with this we come to the conclusion of today's class. A register we have seen that is a group of flip flops that can be used to store binary data. 1 bit of information storage requires use of 1 flip flop. Parallel input, parallel output option for data storage requires largest number of input ports, while serial in, serial out requires the least of the 4 possible varieties that you have seen. Okay. The trade-off associated with serial mode is using serial in, serial out is larger number of clock cycles required to complete write and read operation. Okay. So, there is that trade-off. Okay. Whenever you go from parallel to serial. Serial out read operation on its own is destructive, but if you can put additional circuitry, then using feedback which performs rewriting of the data back to the shift register, then the non-destructive reading can be implemented. Okay. Thank you.